Okay, I think the next section here I'm going to go through is going to be a little short because you don't have to do a calculation for me, but I'll ask you a bonus question about this. All right, so weighted average is a calculation maybe you've never done before. So if you found a 4-leaf clover, you've looked for them and found one. You know you got to look through a lot of clovers to find one usually. And let's say there isn't such thing as 5-leaf clovers or 6-leaf or 7. You do occasionally find other ones. But if clover have 3 leaves and sometimes they have 4, what is the average number of leaves that they have? Well, your intuition's probably telling you it doesn't sound right to say that they have an average of 3.5. Because why would it be in the middle when they're so hard to find ones that have a 4th leaf? Well, that's the idea of a weighted average. So let's say you have a certain yard, and every time you go out, for 1,000 clovers, you find one that's 4-leaf and 999 that's 3-leaf. You can calculate the average that ought to have, and your intuition might be telling you, if you're going to calculate and it's not 3.5, which numbers are going to be closer to? Is it going to be closer to 3 or closer to 4? So if you find 999 clovers every time with 3 leaves and 1 clover that has 4 leaves, you're probably going to think that it's going to be closer to 3, which would be correct. But let me show you how to calculate it. What you do is you change it to a decimal form. 99.9% of them, or 0.999, have 3 leaves. 0.001 has 4 leaves. And you multiply 0.999 times 3, try it on the calculator, you get 2.997. You multiply 4 times 0.001, and you get 0.004. Then you add, and that's your weighted average. Slightly over 3, 3.001. That's how you do it. It's pretty simple actually, because you have a multiply problem, you write down the answer, multiply problem, you write down the answer, then you add. Well, you know how to add, you know how to multiply. So if you just do those things in the right order, you can get a weighted average. For example, when you have protium, deuterium, and tritium, hydrogen 1, hydrogen 2, hydrogen 3, this guy is exceedingly rare. So rare, it's not on the calculation on the next page. This guy is quite rare, deuterium. But hydrogen 1 is very abundant. Well, these numbers here, these relative masses, have to be found in a lab, and these would be what we would give you. And then if you did that calculation, that relative atomic mass ends up being the one in the table. I'm sorry, the average atomic mass, but it's a weighted average. Notice that it's real close to this, 1.0078, 1.008, because the vast majority is this kind. There's a little bit of this and not even enough of that to notice. So hydrogen 1 is 99.985%, almost all of it. When you multiply these two, you get the number. This one, 0.00015. That number doesn't change much, so the average ends up being very close to what this is. Okay, I'll ask you a question about that.